Recording in progress.
Hello, everyone. Well, we're back after some hiatus for our summer school and summer camp, and we are doing a Wolfram language design review, part of our incremental language design series. All right, we've got a variety of topics. SubmatrixReplace. What is this for? And what is, okay, nest while graph. Okay,
So,
I'm totally confused.
So we'd originally talked about nest while graph was something you wanted to look at, and we started putting the items together for this. And I was also told that, okay, there was a discussion of this and it dovetailed with the SubmatrixReplace function, and the two of them kind of got squished in the agenda here. Charles is supposed to be here and maybe has joined in since I peeked, but we wanted, these were two things that I've been getting pinged on that need to be on the ILD agenda to look at. Right. And so we put them
to my mind. Nest while graph is just seems like a good thing. So just so I understand how it works. Why on earth is this still wrong here?
It's not wrong. It's perfectly correct.
No, we're not.
I've responded to every email about it.
This is not right. This has to be changed. This looks stupid and we got to change it. Okay, so figure out how to get it changed.
Let's
figure out how to get it changed. I know you have a publisher ID and you have an author name.
Other way,
so make sure. Yeah. Right. So therefore, we need to figure out how we're not going to have something like this, where the publisher name is the same as the author name. Tell people if they're going to use their name and it's the same as the publisher name, don't use it. See what I'm saying?
I don't think that's a good constraint.
Well, this is not going to work. I don't want to see this again. We've been through this many times. Figure out a way to solve this. If you can't figure it out, I'll figure it out. But that's my suggestion.
What are you objecting to?
The fact that the same name is listed twice. It looks stupid. Anybody
will the second name ever be anything? Will the second name ever be significantly different?
Yes, it could easily be.
Wolfram Research.
Yes, exactly. That's exactly right. That's the publisher that owns the resource, and it's not a one-to-one relationship. It could be.
Okay, well, then why don't we say contributed by and then vertical bar publisher : if we really want to say that. I'm not really comfortable with that, but we got to do something to solve this.
Well, I'll point out it's not literally the same name twice.
That was a piece of humor, Itai, right?
No, right? I mean, right? It's Bradley versus Brad. So how do you expect some automated system?
No, the automated system isn't going to do it. The automated system, we got to tell people not to do this.
Okay.
I mean, I assume that there could be some sort of distinction in the types of accounts of like, this is a kind of, if they're basically accounts for individuals versus accounts for quote unquote publishers.
That's a good idea.
Well, but I don't know if there are going to be cases where, for example, there'll be something that's published as from Wolfram Research, like where the creators, but maybe we can.
But it can also be an account for an individual, but in here, say Bradley worked with his friend Samantha, and he writes Bradley Klee and Samantha Jones as the contributor, right? And so single person publisher account.
Could you guys please try to solve
of other people?
If you really can't, we'll come back and we'll talk about this again. But please try to solve this. Okay. If you really, really can't, I'll try and solve it for you. But I think you can solve this. Okay. So we never end up with something like this. If it ends up, even if it says. Also, for internal people, it doesn't make sense to have them be the publisher.
Well, if they use the Wolfram publisher account, we don't even show it. But if you're publishing on your own publisher account, then it's treated like internal.
Then we need to tag it in some way. Okay. So we don't get this. All right, let's go look at this function. I assume we have Brad Klee here, right?
Hi.
Yes.
The answer is yes. Okay. I don't know whether it's Brad or Bradley now.
Either is fine.
It's an equivalence class. Okay. Okay, so on every tentacle, it goes on until tests is no longer true. Is that correct?
Well, I think it works pretty much similarly to nest while. The way that I understand this one is that it's just a wrapper for nest while in the same way that nest graph is just a wrapper for nest.
Okay, I want to understand that with more precision. If the tentacles down here to the right, okay, so let's imagine that I say, help me out here. If
Well,
I
I think the testing function applies to the whole graph, doesn't it? Not to the
surely it shouldn't. I mean,
well, it can, because in like with nest while, you can specify in the conditions whether you want, it's a breadth first search, and you can specify how many recent levels you want to look at.
okay, so why did that do that? I don't understand this. Isn't that asking for
Because
all
the
nodes?
graph was used for the slot there.
hashes the whole graph.
Which is not less than 10.
But that's not what we want this function to do. I mean, nest graph takes, right? Nest graph takes this and
With I guess there's two sort of, right, there's an inconsistent thing that's happening, or like nest while does two different things, right? So first of all, hash in the test for nest while is generally the same as hash in or hash one in the test is the same as hash, in the iterating function. But then the problem is you can ask for there to be a hash 2, hash 3, hash 4, etc., which would be the previous, the previous n items. And so the point is you can't really represent those. I mean, I guess you maybe could in a test, for nest graph, where that's sort of the path that got you to this point, but there might not even be a unique path. So it's kind of
exactly. Because it's already done the merging. In the nest graph, it's already merged. So I don't think this is right. I think that test should be on every tentacle test, because in nest, right, there's a single thread here, right?
No, but sorry, but by every tentacle, what happens if you use the fourth argument? You say 5, right? So it gives the most recent 5 results to test.
That's just got to be weird. Well,
does it just pick some arbitrary path back to the starting position?
Can I interject here?
Yeah.
If we're talking about testing on tentacles, then I think really that's more of a depth first search than a breadth first search. The way that the breadth first search is working is like, it's going to take whatever that iterator is and generate successive levels, and it generates the successive levels all at once. The depth first search is just going to choose
right. So it needs like a tree. Do we have our trees people? Do we have Ian here? Yes, we do have Ian here. Okay.
But
so
I should point out that recently, over the last month, while we were breaking here and doing the summer school, there is a new resource function, depth first search, which then does have testing on the tentacles.
I understand, but I that's good. But I think that the real point here is that this is actually complicated and depends on the traversal order.
Well, not for a breadth first search, I don't think, but for a depth first search.
Well,
yes.
it depends what you mean. I mean, there's a foliation here. You're slicing it at some level, right?
Well, there's automatically a foliation because Nest, while it's operating, has these stages that first it does the first stage, and then it does the same thing again to every element of the first stage to get the second stage.
I understand. But I mean that although in a tree that's one thing, but some of that tree element could be equivalent with something over here, right? It could be equivalent with something at a different level. See what I'm saying?
Yeah, and the game graphs that we did probably have a lot of examples.
Well, look at this. This has an example right here. Right? See, that level is different from that level.
Yeah, but things like that happen all the time in the game graphs. And with the game graphs, kind of what you're doing with the nest while graph is similar to fixed point too. Because you can put a condition into nest while graph that I guess essentially does the same thing as fixed point.
Oh, you already had it in there.
Yep, replace. It's fine. Thanks.
Okay. In future, I should open it from there. Okay, but good. Thank you for putting it in there. Okay, so look. The problem with nest while graph is it's a really worthwhile function for us to have. It's something we've used over and over again, but it is unclear what the termination condition should be, because here we're saying, well, go at most this number of steps, right? And equivalence things. I mean, this
Yeah, and
threat
that-
first.
And that is, go a number of steps is the same thing basically that nest does. So when I was making this for the games post, I just said, okay, we'll do nest while graph and make it behave almost exactly the same as nest while, except that maybe it's doing a little bit.
I understand, but Brad, what you're saying is it's not doing the same thing because there isn't a single thread of expressions. In nest, there's a single thread of expressions. Here, the thing that it is applying itself to is a list of expressions, correct?
Yeah, there's one minor difference, which is that these nest while graph, when they see a list in the first argument, it assumes that it's splitting those out on branches.
Yeah, I know. But what it's doing is, the whole point is that the while is applying, well, you're making it apply to the whole graph, which I think is just, I don't know. It doesn't seem particular. I mean, then it's trivial to write this function. I mean, this function is just nest while on, isn't it? What is it? It's like a nest.
The iterating function just
Wow.
calls nest graph at depth 1 or something. Or I guess actually no, it needs to keep track of the frontier, so never mind. But
Right, but the thing is, okay, so what you're doing here is you're feeding to the test the full graph produced so far, correct?
Well, I think maybe we should look at some more of the examples that are
No, just answer that question. Are you feeding to the test the whole graph produced so far?
Yes, or you can, if
No.
you want to, you can change it around and say feed it the last two graphs that you've calculated.
No, I understand, but it's the whole graph computed so far, right?
I'm just looking at the first basic example, and that's what it looks like to me because it says go to.
Yes,
yeah,
okay.
vertex count, right?
Yeah. I mean, that's not obviously wrong. It may be the only consistent thing to do. It's just what I would assume is that it's on a tentacle. So
Yeah, so if we want it on a tentacle, my basic suggestion would be to look at the other backtrack search thing and see if we can merge these functions somehow to have nest while graph be an intermediary between depth first searching and breadth first searching.
right, we've been through things like that before. It's complicated. It's all about traversal order again.
Yeah.
Right.
Well, I
So-
think
Although I'm not sure the traversal order really matters a whole lot, does it? I mean,
Oh,
it's
it
basically
does.
just each each vertex is just going to like.
Here's why it does. Here's why it does. Think about this. If we didn't get down to this vertex here, this graph would have a different structure. In other words, if we only saw, if
But
we only
eventually,
saw
it's
this,
going to either see like look. If basically imagine you have this sort of growing graph, and at each step you I don't know if nest graph applies to all the vertices or only the quote unquote frontier vertices, but it doesn't even matter. You know, you look at you look at all the vertices, and you apply this function, and then all you do is you say if this vertex satisfies this condition, then I apply this function. Otherwise, I don't apply the function. And then the version where you care about history, maybe it would be something like I look at this vertex, I look at the shortest path back to one of the sort of origin vertices. And
yeah. But hold on. Sorry, Ian said something. It is only doing it at the frontier, right? Nest graph is on.
no,
it's growing it at the frontier, I think. Because
Right, but
if you apply it to
Well, if your functions are pure, then it might look like it is, but it does in fact apply the operation to every vertex in the graph.
but it doesn't list duplicate edges. Like if you apply to this function all the vertices, It seems like you should probably
Yeah.
just be duplicating the earlier edges.
Right.
But it
should
might be
that
removing. I mean,
algorithmically.
this is related to this question about whether it assumes the function is deterministic.
Right. Which I think we're agreeing it does, right?
Well, I think in the beginning it didn't. So I think the idea was there'd be an option where it
I
would.
thought we are now assuming that
Or
it is
no.
deterministic, correct? Can somebody confirm that, please? Who wrote this?
Who wrote what?
Nest graph. Who knows? Okay.
I thought it was Charles, but he's not here. So
Did we change this so that it is determinate? It assumes it's deterministic. We were supposed to. Okay, where is Charles? I thought he was.
I know something with nest graph related to this was changed, although I don't remember exactly what.
I believe we are assuming it's deterministic, but let's check that. Could somebody please track down Charles? Do I
Yeah.
need to?
Just do nest graph with echo in the function, and we will immediately be able to tell. We maybe want to echo hash, so we can see if it hit the same. Well, actually,
Yeah,
no, sorry,
it looks like, yeah, the change was made because you have
Yeah.
no repeats.
Yeah, there are no repeats though.
They're. Oh, yeah. But see, this doesn't even change what I was saying though, right? Because the point is, it doesn't even matter if it's depth first or breadth first. All that matters is just you have a test that applies to a vertex, or maybe applies to a path from the root to the vertex.
Yeah,
And it doesn't matter what your traversal order is. The path, if you have a vertex, you always know what the shortest path from the root to the vertex is.
You're
right?
advocating that both the test and the termination happens locally, whereas what's implemented in the function repository now is both the test and the termination happen globally.
Yes.
Well, I think I don't know which is. It seems like the local one will be more useful, but I'm not sure if the global one.
Actually,
that could also be useful. Yeah.
Can I say two things actually? I think that if you test global, you can also test local.
Obviously.
That's one thing. And then the second thing is that why the traversal order matters. If this is actually a search and you're looking for some particular item, then whatever heuristic you put in there to do the traversal orders will determine how long the search takes. And those heuristics,
yeah, right.
It's a huge field of optimization.
Yeah. We know.
Well,
okay.
But two things. If you can control it globally, I don't think that means you can easily control it locally. I mean, you can with some effort, but the point is, if you control it locally, you can do things where this side keeps growing, but this side stops, which you can do by modifying the first argument of the nest graph. But I don't think you could do it by modifying the third argument in the global case.
Yeah, I agree.
Hold on. Would Nick like to make any comments?
In regard to that, what?
About what behavior? Okay. So what I'm advocating here is that nest while graph look at locally at the nodes to determine whether to terminate. Now, maybe we should table this until we've got more multi-computation functions working, because this is precisely one of those functions. It's like theorem proving, right? Nest while graph could be thought of as a theorem prover. Nest while graph, it's like you're trying to reach a particular result, and you're going to make the graph until you reach that result.
Yeah, but if we're talking about just one result, that really sounds like what's going on with
No. We're not just talking about one result. We're trying to make a function which is a general function. But the point is that if what matters is whether we, if we want to prune it locally on the nodes, that's, for example, because we have a single result we're aiming for, that will be a thing to do.
Right. If you had a single result you're aiming for, that's one where you'd want a global condition. That's actually a good example of a case where you want a global condition. If you want to just grow it infinitely until you find, your theorem that you're looking for, you just need to basically say member queue of vertex list of G, blah, blah, blah. If you were doing it locally, you wouldn't be able to do that because, this tentacle over here has no idea that that tentacle over there found the answer.
I see what you're saying. I see what you're saying. That's an argument for a global test.
Right. But I think that's honestly, I think that's a fairly niche use case because in that case, you really don't care what the graph looks like once you've done that. You just care that you found a path to the result. I mean, only for sort of curiosity might you want to see the whole graph. So I think the local case is still much more common.
Can we have the testism function with 2 arguments and receive both the nodes and the whole graph?
Possibly.
Does it terminate the whole thing if it's true, or does it terminate just remove that one vertex
Yeah, that's
from the
the
frontier?
question. Is whether it's
I think it's 2 functions. I think it's nest while graph and nest vertex graph or something, or nest while vertex or something. I think it's 2 functions.
Or possibly put an option in there saying how the test should be applied.
No, not a good idea. We can't change the global behavior of the function just for an option. But let's see, we have Charles here, I think. Is Charles here?
Yes. Hi, I'm here.
Okay. So nest graph assumes the function is deterministic. Is that correct?
Yes, in principle, yes.
Okay, we should say that in the documentation.
Right, and the effect of that is that it only applies the function at the frontier as opposed to all the vertices. Is that right?
Charles?
Yes, I'm just thinking, when you say at the frontier, what do you mean?
In this graph, as it continues to nest, it only applies the function to nodes to which it has not already applied the function. Correct?
You mean next graph? Right, yes.
Okay, yeah.
But if it was not deterministic, it would have to apply it to everyone again, which I don't think it could really consistently do.
Right, yes.
Okay. All right, fine. So, okay, what I'm trying to understand, partly from Nick here, is whether we are just making a junior version of these various multi-computation functions, and we should not do this, or whether this is a simple case that we want to have independent of having the general multi-computation functions. Nick, can you comment on that?
Yeah, it's a junior case. I would like to more local condition if you ask me. It's like I imagine that it's like just a bunch of crawlers generating a graph, and you just specify a condition where for each of them to stop.
Okay, but I understand that. But multi-way graph is something which is essentially the same as nest graph, is it not?
It doesn't have the termination condition.
No, I'm saying multi-way graph.
Yeah, not nest while graph.
Multi-way graph is the same as nest graph, but keeps a bunch of additional information, correct?
Like tagging, for example.
Like tagging and branchial graphs and causal graphs and so on.
Yeah, basically, if it contains the information about events, everything else is also computable.
Although I think there's value in having a very mechanistic, simple function, as opposed to sort of asking people to use some.
No, I agree.
Function with an intimidating name.
Well, forget that function is not a built-in function yet. We want it to become so, but it isn't yet. And so the question is, But
I mean, it's like how we used to before block map existed. You could do the same thing using the pure function rules of cellular automata, right?
Crazy.
And it's like but that was the explained. Oh, we don't have this function because you can just do it through cellular automaton. But that's it's true, but it's crazy.
Yes, I agree. But just so I understand, from the nest graph alone, which is the same as multi-way graph, one could compute the branchial graph purely from this graph, right, Nick? Yes, obviously, right?
Well, it depends on what definition of branchial graph you're using.
There's a function on a WFR which should do that already. We used it. We used it for the games post.
But the question is, it's assuming a certain breadth first traversal order, right? It's assuming that you're going, is it not?
No, you can specify the foliation if you want to.
So you're saying there's something here.
Yeah, and I used it actually to lay out some results I got on polyomino puzzling too.
Okay, but hold on. Branchial graphs. Is this the one?
Yeah, I think so.
It doesn't take affiliation, right?
No, the foliation is optional, but if you don't give it a
affiliation is a list of layers of vertices.
if you don't give it a foliation as an option, it assumes the minimal foliation. And then my definition is in vertex stratify on the WFR too.
Okay, so this here, very exciting, but is the branchial graphs for this. I don't know quite why it needs to have the list here. Okay, so what is the way of specifying? Takes an additional option of this form. Lists a vertex and a subset. I see, that's pretty nice actually.
Thanks.
Ian, do you understand how this is working? Do you understand what this is? Okay, I think you should understand it, because this is basically giving a list of vertices that are considered to be the successive time steps, right? So in general, what this is doing is it's showing you which, the branchial graph is telling you for these two nodes here, because they have a common ancestor, they should be connected. Those kinds of things, right?
If they're on the same foliation level.
That's correct. That things in the same layer of the foliation should be connected if they have a common ancestor. So what we're defining here, which is perfectly nice, is and perfectly general, I think, is what the successive foliation levels are.
Yeah, and that's a combinatorial problem that we also solved and discovered something about rigidity of graphs, that there are certain graphs, directed graphs, which are rigid with regard to the foliations, but most of them are not, so that ultimately you get a lot of different options for the particular foliation without having to change the overall length of the time axis.
Yes, but I mean, how would we typically find, in this graph, how do we typically find, is it the vertex, it's the vertex out component of the root node at a certain level would be the naive foliations, correct?
Well, if you just look at vertex stratify on WFR, that will pretty much allow you to calculate them all in a pretty well-ordered way.
I don't really quite understand what this is doing. Okay, so if I say vertex stratify of this thing, okay, so what is that doing? That's basically just doing the levels here. But why is that not the vertex out component? It's a table of the vertex out component. Am I wrong here? Okay, I don't understand why those are different. Can you explain?
I think the reason is because, like, when you get to vertex 4, probably, it needs to have 2 and 3 as an input. So it can't be listed on the same level as 3.
Basically, you can't have the foliation having the same time like separated vertices.
Okay. To what extent should we have functions that are for dealing with post sets where we just these are basically anti-chain? Is that not correct?
Yeah.
The other pre-existing function that this is similar to is find graph partition. But
Is that a WFR function?
no, it's built in, but it's built into the language, but it's not complete currently.
I've never heard of it.
Roger says that this is a really important function. I think he's right about that.
Charles, can you say what this is?
Well, so graph partition essentially partition your graph in a equal, approximately equal size part, where essentially we're trying to minimize the number of edges between the different parts. And you use that a lot in terms of like partitioning job in a parallel computer, right? You want to minimize the weight.
Or communities and things like that. Is that right?
Yeah.
It fall more in that category, but this one is more about essentially the weight on your edges. So you can actually partition. Is an optimization problem, right? So you want to minimize the transfer, the communication in a equal size part or in your graph.
I understand. I think it's a little different from what we're trying to do here. Okay, so look. Okay, we've got several different questions here. First question is, I think we want a nest-while graph. I think, as Christopher says, despite the fact that it may be a special case of multi-way graph, it's, there's value in having that simple function. So now the question is, does it have a local criterion or a global criterion? The global criterion is certainly more general, which is an argument for it, given that this function is, and this function, nest-while graph, would be essentially a fundamentally breadth-first operation.
Wait, sorry, did you say that the local, I don't think not either the local or the global constraint is more general. There are cases that
yeah, they're different.
That one can do and the other can't do for both directions.
Fair enough. Okay, well, let's imagine that we had a nest-while graph that is the global constraint. Okay, where it's, function init, and then, then the same arguments as nest-while. Make sense? Now, what would we call the other one? So okay, so that it's the same arguments as nest-while, where this test is always applied to the full graph.
Really, what it is, it's this is not the actual names, but really what it is it's nest graph while versus nest while graph.
It is. Yeah,
nest graph while is you keep running nest graph until this condition globally holds, versus nest while graph, which is like you're running nest while down all these paths.
Yes, you're right.
Everyone will understand that right away.
Yeah, exactly. It'll be very understandable. No one will be confused. Right.
Okay. Right. So I think nest graph while is the right name for the thing that's currently implemented in the function repository. Comments from people. Now, then the question is, what will be
I'll make a comment. The reason I called it nest while graph is because graph is the output.
I take your point, but while is not an outputting thing. It's a reasonable argument, but okay. So given that we have these two functions to name, this nest graph while, I think we can understand that is just doing the same as nest graph, but with a while end condition. So now what on earth would this be called?
I mean, we could use the names, local and global, but it's a little weird.
It's weird.
A little long.
I mean, it's vertex would be the
but it might not just apply to a vertex. It might. Well, I don't know if we're going to support the fourth argument.
Nest vertices while.
Why can't the global test just have an additional argument for particular path where it is currently at? in addition to the global graph. It's like a supplied function.
So
can
you would just
supply
use
with
false
with
as the third
additional
one.
stuff.
If you wanted to do all local, you would just have false as the third argument.
Well, you're talking, but by the way, why isn't supplied on our agenda? That's like one of the most, these are some really important things, because supplied will get us out of this box.
Yeah, I mean, supplied is also something that's being actively discussed in LCC. It's not
okay, fine.
entirely contained to one thing.
Fine.
Yeah.
Right. Well, there's already something a little bit like it though in nest while and nest while list, because there's the I think it's the fourth argument is the number of slots to feed into the function, isn't it?
Yes, it is.
Yeah, but I think that nest while graph has something similar where if you supply that the M variable, most recent
Yeah, I know.
results.
Right. It gives you the last
results,
M graphs. Yeah.
The results in this case are the last M graphs.
Right.
Yes.
But I'm just thinking if we had a combined function that supported both the local and the global, and we also wanted to be able to specify an M for the local case, then it's not totally clear what the argument structure would be to that function.
Could
that
the
you give.
argument be an association with keys like graph?
Let me point out, we've got two things going on here. The horror of breadth first search, a very unusable function. We do not want to end up with that, because we've got some of the same issues there. Breadth first search.
You mean breadth first scan?
Breadth first scan, thank you. Oh my gosh. It was not what I wanted. Yeah, this to me is unusable. I mean, I've never used it.
Well, when I was implementing the depth first search, I did figure out how to use depth first scan and compare them.
Well, it's I mean, when we added this, what we call actually graph programming, right? Is more depend of what people actually want to use. So this was a more general open-ended function, right? And we should probably specialize it and provide some more special cases. But this kind of give you that general abstract way to actually manipulate it.
I agree. I'm not convinced about the design of the thing. I didn't like it when it was first presented, and I still don't like it. It's really complicated.
I think it's just that breadth first scanning, algorithms, they keep different algorithms keep different information, and they care about different things, and so it has to be this big floppy function.
Well, maybe supplied is the way out of that box. Is that possible?
Yeah, maybe, because I think the main complication comes from which, what information do you have to give, to give to the scanning function?
No, you see, the scanning function are more kind of a feedback function. The function by itself, right? You don't actually need to give all those events. You will, the breadth first scan is just work, right? It's now, while you are traversing the graph, what do you want to get? That's the question, right? Maybe it's the way we document it that we kind of emphasize the event first, and it's what confused people. But we can just drop the event and say, okay, well, now when you traverse the graph, you can get information about
what
you
is
are traversing.
Okay, I mean, what is the default? I don't quite understand why that isn't an association as the third argument of breadth first scan.
It was 10 years before association, so we can convert it to that.
Okay, but if we did that, then I'm trying to think. Then I mean, breadth first scan with just a function as the third argument without that list. Does that work or not?
It should work. The first two arguments should work, principle. Or actually, just even one argument.
Okay, so if we say,
wait, what does it do in these cases?
So you just do a breadth first scan and return you the actual predecessor, right? So which gives you the tree.
The hell does it have to do with a tree? I mean,
So,
as far as I'm concerned, a breadth first scan is feeding some function mean, and I don't understand why the function isn't first, because scan would have the function be first.
I think a breadth first. I mean, the tree is basically just that a breadth first scan defines a spanning tree on the graph. You know, where each node is labeled with the index and when it was visited, something like that.
Okay,
Exactly.
that's lovely, but that's very similar to one of these graph stratification things. And that is not what I would expect a function called. So this is why I've been irreducibly confused by this function, probably, because I thought a function called scan was actually somehow going to, I mean, to my mind, that is something that is essentially graph map, just like we have tree map, right? That takes an F and somehow walks through a graph applying F to its nodes, if I'm not wrong. But I don't know what the result of that is. I mean, in other words, maybe that's silly, because in the case of tree map, the tree has a payload at every node to which it can apply the function, if I'm not mistaken.
I mean, there could be something. I mean, there are times when I've wanted to have a vertex map that takes a graph and a function and returns a graph. But I mean, part of the thing is,
isn't it vertex replace?
But see here, I mean, we follow at the time we try to map our usual convention, but here is more a traversal. That concept we don't yet have more generally in the language is you have an expression or a graph, and you just traverse it. It's a visitor, pretty much.
Right. So one possibility for a traversal would be a list of nodes, either the names or the names of the nodes, basically. A traversal is a list of nodes in some order, which is what, for example, in this vertex stratify, that's an example of an anti-chain, a sequence of anti-chains that correspond to a traversal, a visiting order for nodes.
Right. Yes, and the equivalent for the breadth first scan or this function, this traversal, is when you specify the visitor function to be discover vertex.
Blah. Okay, let's try it. Sorry, I'm just that the blah noise is because I think it's very obscure. Okay, so how do we do this now? What's S?
So S you can put 1 is the root vertex. And you can put discover vertex goes to, and then if feedback, you can say print or echo or something.
I don't really like that. I mean, that's going to go, okay. What's that?
It's a 3-argument echo.
Yeah, so it
do echo of a list.
What do you mean?
Do echo at star list.
Okay, what are we seeing here?
So the first argument is actually the vertex is actually traversing, he discovered, right? And the second argument is the predecessor. And the last argument is the level in your traversal.
So how does that relate to? So why are there only 3 levels here? I see 4 levels at least here.
No, the root is 0. Yep.
So this is 0, 1, 2, 3, 4. So in this case, if I said the vertex stratify thing, okay, I'm now confused. This vertex stratify says 1, 2, I see 1, 2, 3. Okay, is that right? So wait a minute, that's level 2. I don't understand. This says 4 is on level 2.
Well, so 4 is a distance 2 from the start vertex, which is what breadth first scan does. Vertex stratify looks like it's basically a level specification where you have to take a max.
I don't understand that. I mean, so vertex stratify is the anti-chains, correct?
4 is at both a distance 2 and a distance 3.
Yeah, so the breadth first search takes the min, while the vertex stratify takes the max.
Right.
Why is
It's like how negative levels you do the highest maximum level of your children.
Yeah, right. Why is vertex stratify? Why is it sensible for it to take the max?
Because you also want to input this function to a directed acyclic evaluate. And in that case, you need to have all of your inputs satisfied before you move on to computing something on the next node.
Okay, let's understand for other people what directed acyclic evaluate is. I am utterly unconvinced by its name.
Sorry about the name.
I like the functionality. Okay, so for people's benefit, what this does, why on earth is that so complicated there? Oh my gosh, what is all of that doing? I thought what it was doing. Go ahead. Sorry, what were you saying? Brad, what were you saying? Hello?
We can hear you. Brad might have got disconnected.
I think most of it is just constructing an actual graph.
I know. I don't understand why it's there.
It
Oh, but
should have just been like put there in place, the argument as a graph.
No, but look, there seems to be a hash sign there. Oh, what is all this?
You just evaluate this graph in place, and I think that would be a better example.
I see.
Brad, are you back now?
Yeah, I got booted or something. I don't know.
Why does this not work? I was doing evaluate in place. Oh, because I have to do the whole thing. All right, this is really confusing. This is really confusing. I'm putting the 10 there, right? Forget all this stuff. And now I've got a graph here. Okay, so now what does this do? What does it do when it says evaluate that? What does it do? I thought what it was doing was, yes, something like this, where you start with a given thing and then it has a function that it applies, doesn't it?
Yeah, that the default function is path count, and the path count on graphs like this just basically does linear.
This is a super confusing example. I'm sorry. You really should change this example. That example is just unbelievably confusing. Something much simpler. Okay, so the path count happens to recapitulate these things here.
Yeah, I think there's probably a theorem that says something like, for any linear recurrence, you can always make a graph structure in which the path count will tell you the linear recurrence on the nodes.
Okay, fine. It's nice, but okay, look, okay, practicality here. We've got some other topics we need to cover today, but we really need to, okay, so I think we need a custom meeting about graph scanning. And to me, we're going to need to introduce a collection of functions, and Nick, I think this is very much on you as well. A collection of functions that implement some of the multi-way functionality, or basically all the multi-way functionality in the end, but that also have easy to use things like nest graph while. And also, I mean, I really like the way that what is it? The thing, oh my gosh, the thing that has the possibility of having foliations in it. Is that nest graph while, or is that something else? What allows the foliation option?
Branch graph.
Oh, branch graph. Yeah, that's the one. Yes. Okay.
But this directed acyclic evaluate on the next version that we make should probably also allow foliations.
Okay, can you explain to people what is directed acyclic evaluate?
Well, I mean, the the fast Fourier transform example is probably the best one that's in there.
Just explain what it is.
If you have a graph that describes some sort of computation where you have different values calculated over the vertices, and the directions of the edges tell you how those values get sent through the graph, then you can also specify a function on vertex that tells you what to do with the inputs before it sends them out as outputs.
Right. So does it send out the output? Does it send out the same output to all the outgoing edges in the graph or not?
Yeah, I think so. Yep.
Okay, so if it had multiple ports, this would be very much like a net graph type thing with multiple ports, where it brings in, it's basically the flip way round of an evaluation graph, or a trace graph, if I'm not mistaken. Ian, can you comment on that? Where it's taking in values where every node has a value, and it's taking in, and every vertex is computed from its.
This is similar to treefold. The difference is treefold is it's basically bottom up, and this is top down, and this is for graphs.
Right. So it's basically giving the data flow of values from vertices, how they feed into new vertices based on a function applied to previous vertices. And what is not obvious is for a graph that's like a cyclic graph, obviously that doesn't work. This only works for a DAG.
Yeah, that's one of the main problems we have right now, that I think we'd really like to solve this problem in the multi-computational paradigm, how to do the cycle truncation and get effective computations out of graphs that have lots of loops in them.
Well, I think that's another one of these foliation problems.
Yeah, it is kind of. And I talked about this with one of the summer school students recently too, who was doing the chess problems. And his idea was just to put some backtracking on top of the evaluator there, which that can work.
Well, the real multigraph doesn't have any cycles. You only have cycles when you introduce equivalence between your vertices. Before that, it's just a tree.
Right.
So you don't have to do anything like cycle.
If you're doing it on a multi-ray graph. Yeah. Okay, listen, we need to have a separate meeting about this, about graph scanning. Okay, I think it's part of the multi-computation series, which hopefully will restart again within this week sometime. I'm sorry, we really need to take a look at some of these other things here just very quickly.
So this is a topic, it may take a little bit of time, but we wanted to kind of get to the central point here. Is there has been a design ambiguity in the way we handle temperatures and temperature differences since we introduced quantity.
Yep.
And the principal issue is, what do you do when you have an absolute temperature in a compound unit? So if I have 3 degrees Celsius per meters, that temperature can't really refer to an absolute temperature. It's referring to a rate of temperature change. Yeah. And so what we've done previously is just implicitly assume that, but because of various relationships in the unit framework, it creates ambiguous cases, like here, where if you multiply Boltzmann's constant times the temperature, depending on your choice of units, you can get totally different answers. And this is something users have noticed and have complained about because it's confusing. And
yes.
Jose,
so what do you propose to do?
So if we go down to the list of proposed changes, there's basically 4 things that we're doing. The principal one is we're getting rid of temperature difference units as a unique dimension. All temperature difference units will be temperature units, regardless of whether they have a fundamental.
Is Michael here?
Yep, he should be.
Yeah, we discussed this. We had a couple of meetings. I think that's all very sensible, in my opinion.
Okay. Has been removed. Okay.
Because Kelvin difference was just Kelvins, but in a different unit dimension, because we needed a different unit dimension previously.
So why did we ever introduce temperature difference units in the first place?
Well, we will still have them. We need them. Because like you have a rod that gets expanded due to temperature, the absolute temperature doesn't matter. Only the relative ones matters. Like the Wiedemann-Franz law even has as the coefficient temperature difference divided by temperature. So both are really of relevance.
Okay, so I don't understand where this is being. So you're saying temperature difference unit no longer exists?
No, no,
No,
no.
dimensions.
The
It didn't say
dimension.
units.
Yes. So this
Okay.
proposal basically is paying a lot more attention to the difference between degrees Celsius and degrees Celsius difference.
And the point is there is no Kelvin's difference because it's an absolute scale.
Yeah,
Exactly.
Kelvin's is Kelvin. The only reason we had Kelvin's difference before is because we treated them as distinct unit dimensions, which was not technically correct, but was.
I see. So the dimensions of a degree Celsius is the same as the dimensions of a degree Celsius difference.
Exactly.
The only difference between the two of them would be one has effectively a absolute zero base, and the other one has a base at 200 and some odd.
So can you take a degree Celsius and divide it by something? Because that doesn't seem to make a lot of sense to me.
So the only way you can do that is effectively by converting it to Kelvin first. So there's
so it will generate a message.
Yep. So there's a lot of examples here, but basically what we've done is say, if you're doing an operation that is ambiguous with an absolute temperature, we need to convert to Kelvin, and we will give you a warning message about it. Because
we will just convert to Kelvins. We'll just do the conversion.
Yes,
you
we'll
say
do the conversion automatically.
Celsius. Right. Okay, and is that a standard notation, that little delta thing there?
So that's the proposal.
Can you increase the magnification bit? I can't see those decorations.
Yeah. So there's basically a delta below the degree.
Is that, Michael, is that something the unit aficionados?
No.
So we invented this.
Yes. So basically, the standards very well say there is a temperature difference. It's not yet standardized, and no own symbol or name has been proposed.
Medical people use Celsius degrees versus degrees Celsius, but many years ago you were strongly not in favor of that. So that's not an option. And just calling it degrees Celsius as we did before was massively confusing if the underlying expression is different.
What do medical people do? I'm sorry, what do
they put the degree sign after the C.
Oh gosh, I always thought that was illiterate. What does it mean?
It means they're talking about a change in temperature as opposed to a temperature measurement. So your temperature changed when you were sick by 2 Celsius degrees, but you have a temperature of, 37
or 30,
Celsius or
39.
whatever. Yeah.
39 degrees Celsius.
Michael, what do you think based on unit?
I feel like this is not acceptable to put a degree sign to the right. But having a visual differentiation, I feel like is very useful and will avoid a lot of confusion at users.
Okay. So the question really is, where do we put it? And do we
exactly
decorate degrees? I mean, we could turn that circle into something that is a rounded triangle, for example, up there. Or is that too freaking weird?
That might be too subtle.
I don't think it'll be that subtle. I think it'll be pretty obvious that's not a circle. Let's see. How do we draw
at normal magnifications?
Why isn't the triangle to the left of the circle? Like delta degrees?
To save horizontal space.
Okay.
I mean, I don't like inventing our own character in general if nobody else has used it before, but we certainly do that on occasion. So it's not off the table. I just think it's a second best approach to anything else.
No, there isn't a standard approach here.
Correct.
And it is the degree Celsius that is modified. It's not the degree that is modified, and not it's the Celsius that's modified. So where the modifier is should be a little bit holistic with respect to the whole thing.
All right.
So do we have this implementation that if you divide the degree Celsius, it turns into a Kelvin or something?
That's what we were saying with a message.
Yeah, we have this in prototype builds. We've been running through a lot of testing. There's some examples here of basically all the unit operations.
This is not bad. This is not bad. This different thing. Go ahead, Itai.
And if you divide the degree Fahrenheit, will it convert to Kelvin or to Rankine?
To Kelvin. So we are using Kelvin as the base since it's the base SI dimension we have. It's unambiguous. Rankine or Ramier are not widely used, and we had looked briefly at you convert it into Kelvin, do the operation and go back, but the results were often confusing. And so, there's basic cases like if you add two absolute temperatures together, you get the equivalent value as converting them into Kelvin. And then if you automatically convert them back, it looks a little weird. And so our sort of central principle was if the case is going to be ambiguous, we want a message, and when in doubt, go to degrees Kelvin or go to Kelvins.
So, all right, so this is I think that wording is less than perfect. Absolute temperature given in degrees Fahrenheit. Converted into a difference with absolute, what? There's not an absolute temperature. What do you mean by absolute temperature?
So
3
degrees
Fahrenheit is a temperature.
Yeah, but why does it say absolute temperature? Because that's smacks of kelvins.
Yeah. So, I mean, the terminology here is a little tricky, but the idea being that degrees Fahrenheit is an ambient temperature or.
Okay, but why don't you say temperature given in degrees Fahrenheit?
So we want to disambiguate the word temperature into two: absolute temperatures and temperature differences.
Okay, but I don't understand. Isn't the absolute scale of temperature is the one with kelvins? I mean, that's the usual usage.
That's the traditional nomenclature. Yeah.
No, not really. I mean, this is the unit used for it. The absolute temperature you can use with any unit you want.
I think
it's the fact that you can convert between degrees Celsius. I mean, right. So in some way, to be totally consistent, what you would do is you'd say the dimensions of degrees Fahrenheit or degrees Celsius is this is a relative temperature, and you can't even convert it to Kelvin. But because that would be kind of annoying and crazy, and because you can convert them to Kelvin, then we're calling them an absolute temperature, right?
It's not actually relative. No, it's relative to the 0 of Fahrenheit, which is itself not absolute in that sense.
Right.
But absolute temperature is more than a own name rather than saying something is absolute. It's a historical name, not a meaning.
I know, but absolute temperature, I thought was usually meant the absolute scale of temperature.
Can we just lose the word absolute so it says temperature given in degrees converted into a difference?
That's what I would have thought. That was what I was suggesting.
Do we create any confusion by removing that word as long as we have difference to contrast it with later on in the same part of the message?
Well, it's a difference with absolute 0. What do you mean?
Yeah, I mean, it makes perfect sense, Stephen, right? You've changed 3 degrees Fahrenheit into 3 degrees Fahrenheit minus, 0 degrees Kelvin. And that is
I see.
however
Okay.
many
All right.
degrees.
Okay. Yeah. That's right. Okay. I get it. That's right. Let's just get some sense here of what things are happening.
For example, now it's possible to divide by 0 degrees Celsius.
Yes, I understand. Why does this work? I don't understand what this is doing. That's a degree Celsius. Oh gosh, I'm confused by this.
So compare with the next line. Notice how unit convert moved.
If you're not in prototype builds, it will error because of the 0 there.
Okay.
Yeah.
But I think if you look at the next line, it's clearer.
Yeah, all 3 of those inputs are consistent.
Unit convert to kelvins of, I see, that second one is 1 over unit convert to kelvins. And the first one converts to kelvins without a message.
Mm-hmm.
Yep.
Because it's the same temperature, just you used an unusual measurement device.
Right. So this is something that the users have reported because there are formulas like exponential of energy divided by kBT, and they want to put the T in degrees Celsius.
Exactly. That is probably one of the most common things.
Well, it looks nice.
Yep. And these are basically cases where if you explicitly insert an absolute temperature into a compound unit, we will convert it to Kelvin automatically and give a warning that, you know, if you meant degrees Fahrenheit difference, you need to say degrees Fahrenheit difference.
Right. Just so I understand, I mean, this whole business with differences was whatever, logarithmic units, how would they be treated in this world of, are they, what are the dimensions of bells, for example, the you know, logarithmic units? What are the dimensions of a logarithmic unit?
Depends which bell.
Well, you could also argue they're not really units.
Yeah, I mean, temperature scales share some of these same problems in that the vast majority of the units framework makes assumptions about zero base and linear relationship between units. And if we're going to talk about unit scales or scale units, we'll probably need a separate meeting just because it's a whole can of worms. But
all right, we should have that. Yeah, go ahead.
Just to answer quickly, so Bell plays the role of kilo or mega. It's just a numerical factor. So it's you need to specify Bell of what, and that determines the units. Sorry, dimensions.
It's again, you have a measurement device that shows you your value on a logarithmic scale, but it's still the same thing you measure.
Right.
So it's like a scaling function, but it is.
Yeah.
Okay, so I didn't really realize that one should think about it like the prefixes and so on.
It's a scaling function relative to something. Do you need also with respect to what?
Right.
Is the additional parameter you need.
I need to run along here, but okay. So look, we've got one meeting about graph scans. I think it would be nice to look a little bit more at these temperature things, although I would say this looks good. From what I can see, this looks good.
It fixes the issues that people complain about most often too, that real users complain about. So that's a plus.
That's a good thing to do. All right. Well, we've got more.
Can you? Sorry, can you look at the ILD attic section real quick? Should be kind of short.
No, takes thought. I don't know.
Okay.
Not sure. I don't know.
Okay, we'll circle back to these another time then.
Sounds good. All right. Thanks, and see you guys soon.